So, if you've ever been around an IBM mainframe, you know it's an absolute beast when it comes to processing data. But have you ever wondered how you keep track of everything happening inside that machine? Well, today, we're going to pull back the curtain on one of the most powerful, built-in tools in z/OS that does exactly that. We are talking about SMF, which stands for System Management Facilities. Now, the best way to get your head around SMF is to think of it as the flight data recorder for your mainframe. It just runs quietly and efficiently in the background, and its main job is to collect and record a just massive amount of information about the system in every job that runs. Seriously, if it's happening on the mainframe, you can bet SMF is capturing it. All right, so here's our game plan for the next few minutes. We're going to start with the basics, what SMF even is. Then we'll get into why it's so incredibly important. After that, we'll follow a piece of data on its journey, figure out how to get that data out for analysis, and finally, we'll make sense of what it all looks like. It's a pretty straightforward path to understanding this really essential Z/OS tool. Okay, let's kick things off at the very beginning. So if SMF is the flight recorder, it's also the mainframe's most detail-obsessed accountant. You know, the one who tracks every single penny. It's the component responsible for keeping a perfect ledger of everything happening on the system. And when I say detailed, I mean it. The scope of what SMF captures is just incredible. We're not just talking about whether a job passed or failed. Oh no, it tracks CPU time down to the microsecond. It knows every single data set that was opened, all the system output activity, you name it. It gathers all this stuff for every single job step and user session, and then neatly formats it into standardized records. Which brings up a really important question. The system is creating this huge mountain of data. So what? I mean, why does any of this matter? How do we turn all of that raw data into something with real, actual value? Well, that SMF data is literally the backbone for so many critical business functions. You want to bill another department for the exact computer resources they used last month? The CPU seconds recorded by SMF give you the precise data you need for that chargeback. Worried about security and need to track who's trying to access things they shouldn't? That's done using records from RACF, the mainframe security cop, and all of that gets captured by SMF. This data is absolutely vital for everything from reporting on system uptime to analyzing resource use and making your job schedules way more efficient. And this quote right here really just hits the nail on the head. This isn't just about what happened yesterday. By keeping and analyzing SMF data over time, a company can make big strategic decisions. You can see trends, evaluate how system changes are performing, and plan for future growth. The historical value is just immense. Okay, so we've got a handle on what SMF is and why it's so important. Now let's get a little more technical, but don't worry, we'll keep it simple. We're going to follow a single piece of SMF data on its journey, right from the moment it's born to where it ends up getting stored. It's really just a simple three-step dance. First, as things happen on the system, like a job finishing, different z/OS routines package that activity into a standard SMF record. Second, that record gets handed off to SMF, which holds onto it for a split second in a memory area called a buffer. And third, before those buffers can get too full, SMF writes all that data out to a permanent storage location. That's it. Creation, buffering, and storage. Simple as that. Now that permanent storage can be one of two places. The classic, traditional method is writing to something called SMF Data Sets. Think of these as special mainframe files where data gets written in small, fixed-size chunks. The newer, more modern method uses SMF log streams. This approach lets SMF write much bigger blocks of data all at once, which can be a whole lot faster and more efficient, especially on a really busy system. All right, so our data has been safely recorded to either a dataset or a log stream. Awesome. But it's not doing as much good just sitting there, right? So the next logical step is, how do we get it out so we can actually use it for all those cool reports and analyses we talked about? Here's a really key concept you've got to understand. You can't just read the active SMF file while the system is still writing to it. That'd be like trying to read a logbook while someone is still scribbling in it. It's a mess. Instead, you use a special utility program to dump the data. You can almost picture a little dump truck that comes along, scoops up all the collected records from the active file, and moves them to a separate workshop where you can safely inspect them. And of course, there's a specific tool for each type of storage. If your SMF data is in those traditional data sets, you're going to use a program called IFASMFDP. But if you're using the newer log streams, then you need to use IFASMFDL. It's a simple but super critical distinction to remember. Just think DP for data sets and DL for log streams. Okay, we've collected the data, we've stored it, and now we've dumped it. So what's actually inside that file we just created? Is it just one giant, unorganized jumble of information? Well, thankfully, the answer is no. SMF uses this brilliantly organized filing system that's all based on record types. There are 256 possible types, which are numbered 0 all the way to 255. A great way to picture this is like a huge mailroom with 256 different mail slots. Every piece of data that SMF collects is a specific type, and it gets sorted right into its matching slot. This makes sure all the data about a certain activity is always grouped together. And this table here makes that whole idea really concrete. Let's just look at a few of the heavy hitters. The super useful Type 30 record, for example, tracks things like how much CPU time a job used. That's essential for both performance tuning and billing. Then you have types 14 and 15, which are all about dataset activity. They track every single time a file is opened for reading or for writing. And, like we mentioned, types 80, 81, and 83 are absolutely critical for security because they record all the events from RACF. The big takeaway here is that each number has a very specific, well-defined job, which lets you zero in on the exact information you need. So let's bring this all home. After our quick tour, what's the big idea you should walk away with? It's actually pretty simple. SMF is your mainframe's ultimate tracking system. It sees everything and it records everything. So let's recap real quick. We learned that SMF is basically the flight recorder for ZOS. We saw that it provides the raw data that's essential for billing, security, and performance. We followed the data as it flows from system routines into buffers and then out to permanent storage. We learned that to get the data out, you use one of two dump programs, IFASMFDP or IFASMFDL. And finally, we saw that all that data is neatly organized into up to 256 different record types. And that leaves us with one last thing to think about. Now that you've got the what, the why, and the how of SMF, I want you to think about what you could do with it. What are those burning questions you have about performance or cost or security on your system that you could finally get an answer to if you just started digging into this incredibly rich source of data?